Okay. Okay, making sure you're still here. Making sure I really did start recording, yes. All right then, all right. There we are. This is what we get to do today. Is this exciting or what? We're going to, well, first you need to notice that you only have 3 homework problems in this set. It's to teach you the basics of solving radical equations, in particular square root equations. And then after this, we have some word problems that are interesting and different, but there are also only 3, I believe. So you are not weighted down with homework this week, so you ought to be able to study the practice exam. I highly recommend it. It does cost 5% of your grade, whatever the points are that make it 5% of your grade. And all of the problems that are on the real exam are on the practice exam. So I highly recommend you do the practice exam several times. It'll be good for you. Okay, so we're going to start talking more and more about inverses. And we're going to talk about inverse operations. Just briefly, inverse operations, operations that undo each other, are addition and subtraction, for instance, or multiplication and division. They undo each other. Well, squaring a number, whatever that number might be, and taking the square root of a number are also inverse operations. They undo each other. Now I'm going to use this set of inverse operations along with the others today. I need to solve for x. This is an equation, so I need to solve for x. But, okay, wait a minute here. I just thought maybe there are some people who are going to be out in the waiting room if I don't just give everybody admission right now. And I may have already done that, but I'm checking to make sure. Everyone. Yeah, everyone can bypass the lobby. Okay. So here we are. I have an x here, I could solve for that, but there's also an x over here and it's trapped under a square root radical. Remember, radical is just that sign. You could have any kind of radical. You could have a square root, a cube root, a fifth root, a fourth root, a seventh root, a 300th root. You can have a whole bunch of different kinds of roots, even an infinite number of roots. Okay, but this sign in and of itself is called a radical. So here I have a radical, I have x trapped underneath it, and nothing can get in or out. So I'm stuck, but I do have an inverse operation I can use, and since it's an equation, I have to use it on both sides. So that's what I'm going to do. I'm going to square the left-hand side of this equation. And I'm going to square the right-hand side of the equation. There. Okay. Oh, what's that 3 doing there? I was looking at a 3. Watch that. It's just so easy to do something like that. Okay, now because square roots and squares are inverse operations and they undo each other, if I square a square root, then what I get is this. But over here, life is not that easy. When I square a binomial that's not under a radical, this is what I get. Okay. So I'm going to multiply these binomials together. I'll say x times x minus 9, negative 9 times x, negative 9 times negative 9, or minus 9 times minus 9. And that's how you do it. Or you FOIL if you know how to FOIL, because it gives you the same thing. Okay, so I will have x squared minus 9x minus 9x. And then I've got negative 9 times negative 9, that's positive 81. Bring down my equal sign, and then I'll have x minus 3. So, on the left, I'll gather my like terms together. If I subtract 9x and subtract another 9x, I've subtracted 18x, yeah. And then plus 81 equals x minus 3. Now we've got a quadratic equation. And remember that when you have a higher order equation, anything higher than a linear, equation, you have to gather all your terms over to one side and set it equal to 0. So that's what I'm going to do. If I subtract x from x, these terms will zero out. So that's what I'm going to do, but I have to do it to both sides. And then plus 3 and plus 3 will zero each other out over here, so I have to also do it over here. On the right, I'll have 0 plus 0. And you know what that adds up to? It adds up to 0. But over here, I will have x squared. Now, minus 18, and then minus another x is going to be minus 19x. And 81 plus 3 is positive or plus 84. So our quadratic equation is going to be x squared minus 19x plus 84. Okay, once we've got this, if you recall back to intermediate algebra, the first method you used for solving a quadratic equation was factoring, and that's what we're going to do here. So the first thing you notice is you've got 3 terms. This is a trinomial. And then you notice that you have a 1 in front of the x squared. That means you can use the easier method of factoring. And that easier method, when you have a 1 in front of your squared term, is you take the 84, here it's an 84, but whatever this constant term is on the end, I'm going to take 84, it's positive 84, and I'm going to factor it. into 1 times 84, or negative 1 times negative 84, 2 times 42, or negative 2 times negative 42. Or let's see, I wonder if 3 will go into 84. Okay, so 3 times 28, or negative 3 times negative 28. Why am I doing this, you're asking yourself? I need to find, I'm not done. I need to find the factor pair that will add up to negative 19. So clearly I'm going to be using these negative numbers over here. And the reason I do this is that yes, 1 times 84 equals 84, but so does negative 1 times negative 84, because negative times negative is positive. Okay, now 4 times 21, or negative 4 times negative 21. And 5, no, definitely not. But 6, let's see if 6 will go into 84. Yes. 14. 6 times 14, or negative 6 times negative 14. And 7, I doubt it. Maybe. Let's see. Well, yeah, probably, because it goes into 21. So 7 into 84 is going to go 1 time. 7, 8 minus 7 is 1, 14, that'll be 2. 7 times 12. I was starting to kind of get nervous here. Negative 7 times negative 12. Bingo, we could go on. In fact, 8 goes into 84. No, it doesn't. No. Okay, well, we're going to stop here simply because I know that 7 plus 12 is positive, equals positive 19. Which is almost the answer. I need a negative 19. But when you add numbers that have the same sign, you get the same sign on your answer when you're adding. So negative 7 plus negative 12 is going to equal negative 19. So now I know this is the factor pair I want right here. Okay, so I'm going to factor. I split apart the x squared into x and x. And then I take these two numbers. Negative 7 becomes a minus 7. And negative 12 becomes a minus 12. Now, taking you down memory lane. The next step to solving a quadratic equation by factoring is that you set each factor equal to 0 and solve for x. So we will have, I'm going to add 7 and add 7. So x equals 7. because negative 7 plus 7 is 0. Same thing will happen over here. I will add 12 to both sides. Negative 12 plus 12, 0 out, and I'm left with x equals 12. And I have two possible answers. But the thing with with radical equations is that you can work every step correctly and get the wrong answer. Because here's the hard part of dealing with radical equations. Whenever you square both sides of an equation, you can come up with something called an extraneous answer, a wrong answer. It's correct for this, but it's wrong for the original equation. As a result, we have to check both our answers. And you'll always have to do that. Okay, so we can let x equal 7. I'll have 7 minus 9 equals the square root of 7 minus 3. 7 minus 9 is negative 2. This is the square root of 7 minus 3, which is 4. So negative 2 equals the square root of 4, which is 2. So negative 2 equals 2. Wrong. They're two different numbers. In fact, they're on exactly opposite sides of 0 on the number line. So I have to mark this out, and I have to take special note that 7 will not work if it's substituted for x. Now, most of the time, the other answer will be correct, but you haven't got a guarantee. I've worked problems where both answers are extraneous, so we still have to check x equals 12. Okay, so I'll have 12 minus 9 equals the square root of 12 minus 3. 12 minus 9 is 3. And the square root of 12 minus 3 is the square root of 9, which is 3. So this one works. 3 equals 3. That's true. And now I know that my only answer to this problem is x equals 12, my only solution. If you put down both numbers, my MyLab counts it completely wrong. You need to check your answers, even though I too find it really irritating to have to check answers. Nobody likes it, but do it anyway. Sometimes both answers will check true. Sometimes both answers will check wrong. Most of the time, one will check wrong and one will check right. But you have to be sure. So check your answers. Okay, next problem is a little bit different. We have solve the square root of x plus 7, and then outside the radical, plus 5 equals x. That would be very hard to solve and would probably take twice as long as if you were to do something else, and that's isolate your radical. Over here, the radical was already isolated, but over here, it's not isolated. It's on the left-hand side with a +5. The +5 is not under the radical, so we can subtract it off like this. Make it bigger. There. Okay, the reason I did that was so that 5 minus 5 would equal 0 over here. And over here, it's perfectly happy. Now we bring down the square root of x plus 7. X plus 7 plus 0 is just the square root of x plus 7. And now we can do to this what we did to the last problem. Now that the radical, now that the radical is isolated on one side, the left side. Doesn't matter which side, as long as your radical is isolated. I am going to square both sides so that I can get that x, the x is what I really care about, out from underneath the radical. Okay, so since squaring and taking a square root are inverse operations, they undo each other, and you're just left with what's underneath. And over here, you're going to have x minus 5 times x minus 5. So x plus 7 will equal x squared minus 5x minus 5x plus 25. So x plus 7 equals x squared minus 10x plus 25. Okay. Now I've got a quadratic equation. So I drag everything over to one side and set it equal to 0. It's always better to drag everything over to where the x squared is positive, because it's just easier. Well, I didn't have to do that. Okay, x squared minus 11x. I take away 10, I take away one more. Plus 25 minus 7 is plus 18. Yes, equals 0. Or you could do the 0 plus 0 thing. 0 plus 0, and we know that 0 plus 0 is 0. Okay, now we've got a quadratic equation, and it is very easily factored. In fact, I mean, it's hard to get smaller than 18. You can, and it's nice when it happens. So 18, positive 18, is going to equal 2 times 9, or negative 2 times negative 9. And I'm not going to go any further because 2 plus 9 is positive 11. And negative 2 plus negative 9 is negative 11. And so negative 2 and negative 9 are the numbers I want. So we will have 0 equals x squared. No, not x squared. X. X and minus 2 minus 9, or the other way around. It doesn't matter. You could have said minus 9 minus 2. Either way, now that you have factors, you set each one equal to 0. X minus 2 equals 0. X minus 9 equals 0. Add 2 to both sides. So x equals 2. Add 9 to both sides. And that'll give you x equals 9. So 2 and 9 are your answers. You go on to the next problem. No, you don't. Because while these two numbers, I'm going to say it again because I'm a teacher and it's what teachers do. Both of these numbers are solutions to this quadratic equation, but probably only one of them is the solution to the original equation up here. So we have to check them both. So I'll have x equals 2, and I'll check that. So this is the square root of 2 plus 7 plus 5 equals 2. I thought that actually might be right. Oh well. 7 doesn't usually equal 2. In fact, it never equals 2. So, that being the case, false. We are going to have to say nope. X equals 2 is not one of the answers. So let us move on and check the other answer, which is x equals 9. Chances are it's true, or it'll give me a true, but that doesn't mean that it always will. So please do check both. Yep, this is going to work. Ta-da! So 9 does equal 9, that's true. So x equals 9 is your only solution. And we have solved quadratic equations. So 2 steps, 3 maybe. You isolate the radical, if there is one. You square both sides. Combine like terms. If you've got a quadratic or higher, pull everything over to one side, set it equal to 0. And then for now, you factor, because we haven't reviewed the quadratic formula yet, but we will. Another one, but that's just like this one. So we can do this or not do it. Why don't we move on? And if we get finished with the word problems, because you don't want to be left alone with word problems. Home alone with a word problem. You don't want to be left alone with it, but we can come back and do this if we still have time. And you have the motivation. Okay, so I'm going to save this. And I'm going to what's called flatten my annotations, which makes them permanent. Sometimes I regret doing that. Okay, discussion. Does anybody want to discuss this before I move on? I am more than glad to discuss on this not quite bright Monday morning. Well, okay. There are only 2 problems here. There are 3 in your homework, but one of them is a video with a problem like this one, but the number's different. And then you get to do this one. So this is to get you ready for some problems you're going to see in the near future. Okay, Yardbird Landscaping has 36 meters of fencing with which to enclose a rectangular garden. Now, what do you know immediately? A rectangle. You're dealing with a rectangle. You're dealing with fencing. Fencing is always perimeter. So you're going to be dealing with the perimeter. I know it says area, but for the moment, what you've been given is the perimeter. And the fact that you've got a rectangle. Well, rectangles are usually shorter, and we call the shorter side the width, and the longer side the length. Okay. And we know that all of this adds up to 36 meters. So actually, we're not going to need this, but I'm going to say the perimeter is 36 meters. Okay. Now, if a garden is X meters long, well, so much for my L's. Well, now wait a minute. We don't have to move that quickly. We'll let the length be Lx. Okay. If the garden is X meters long, express the garden's area as a function of length. Okay, that means as a function of X. So we get to talk about what a function of means. Now notice instead of f of x, they're using a of x. You're allowed, since the first letter of area is a, and we're looking for area. Doggone it, perimeter would have been perfect. But no. Okay. So you would do this, okay, if given you were given the perimeter, and now you're going to be asked to find the area. And we were told that the area is a function of length. And what that means is you're going to have a of x over here, and then somewhere over here, you're going to have an x, or more than one x. That's what being a function of x is. This is the general format of area being a function of length, which they're calling x. Okay, now, but we were given perimeter. Okay, so here's what we would normally do. The perimeter is 36 meters, and perimeter is twice the length times twice the width. 2L plus 2W, but then remembering that L is being called X, we will make that change. Okay, now here's what we're going to do. We know also that the area of a triangle equals length times width. Okay, so if the area equals length times width, what we're going to have to do is solve for X or for W. That's what I'm going to do. I'm going to solve for W, but first look what I'm going to do. I'm going to factor by the greatest common factor because numbers should always be as small as possible. So I'm going to divide by 2 and divide by 2. So the 2 cancels out here, and what I'm left with over here is 18. 18 equals X plus W. Okay, if I solve for W because I need to have X's, then here's what I'm going to do. I'm going to subtract X from both sides. So I'll have 18 minus X equals W because this zeroes out. Now here's what I know. Okay, area equals length, which is called X times width, which we're calling, what does width equal? 18 minus X. Except I should have said A of X, but oh well. And while I could leave the answer like this, the world would not come to an end, probably. Notice that their answers don't have any parentheses. So I'll distribute the x, and I will have 18x minus x squared. Now, I don't have enough information to go ahead and solve this. All they want us to do is choose one of these answers. And so my choice would be C. Oh, okay. That was it for this. That was about as exciting as it gets. I don't know how many of you plan on eventually taking calculus or survey of calculus, but you're going to have lots of problems like this. This is called a related rates problem. And what you do is you're given one form of measure and you have to convert it using another formula. So you're working with two formulas. But that's all there was to this one. So you're given the perimeter. Fence is always a perimeter. The formula for perimeter is perimeter equals to twice the length plus twice the width. And so what we did to make the numbers smaller, we would have had to do it eventually anyway, is divide out the 2, bring it out to the front. Notice that this is just the opposite of distribution. To make this go back to this, I could just multiply 2 into the parentheses, which is distribution, distribute the 2, and I would end up back here. So that let me make my numbers smaller, which made it very, very easy to solve for one of the variables. And since the problem calls for a function of x, then I had to solve for the other variable so I could substitute something with an x in right there. So I would only have x's over here, and there they are. So here's your function that represents the area of this garden. And you might need area to know how much seed to buy. Okay. Discussion. Okay. Now we're going to have this step again. But what this problem does is it walks you through the steps to using a calculator to solve a problem, so you don't have to have as much information. But you've already had intermediate algebra, so you know about maximizing and minimizing a quadratic function. And that's really what we're going to do here. But because you haven't gotten there in the homework yet, they're doing a lot for you just to show you how it would work. Okay. A daycare center has 40 feet of dividers with which to enclose a rectangular space area in the corner of a room. Here's my great artwork showing where you've got a corner of a room. The sides against the wall require no partition. Suppose the play space is x feet long answer the following question. Okay, so we are these are the partitions. Now again, they're letting the length be X. Now notice that the wall makes up part of the perimeter of the play space. The wall is not subject to being moved by us. Probably the wall is brick or concrete or wood or whatever they made the daycare center out of. So that means this side plus this side, call this the width. This side plus this side are going to add up to 40. Just an extra fact we can use. Now it says express the area as a function of X. Well, the area is going to equal, because it's a rectangle, at least I'm assuming it's a rectangle. We don't know that. Yeah, we do. It said rectangular. Never mind. Okay, the area is length times width. Well, they're calling the length X, so A of X is going to equal X times W, but that X in the parentheses means we can't have any W's running around over here. So I'm going to have to solve for W and subtract X from both sides. X minus X is 0, plus W, I'll be left with a positive W equals 40 minus X. So I will have X times 40 minus X. Now you're given 4 possible answers to choose from again, only this time they leave them in factored form. So I'm going to do this. You would choose X times 40 minus X. Okay, now we're going to talk about domain when it comes to a real lifestyle problem. What is the domain of the function A of X? Okay, since we're playing with X by itself up here, and we only have 40 feet of dividers, stop and think about this. If X, the length, were 0 feet long, and we're not measuring in inches, so we can't say, well, maybe it's 3 inches. No, if it's 0, absolute 0 long, then all 40 feet of dividers would be plush against this wall. And there would be no play space. Now stop and think, what if X were 40 feet long? Well, then there would be no width because you've only got 40 feet of dividers. So that means that all 40 feet would be plush against this wall, and there would be no play space. So here's what you know. X cannot equal 0 because then there would be no play space. And X cannot equal 40 because again, you would have no play space. So, well, what if X equaled 1 foot? Then you'd have a very narrow play space that nobody could play in. But, but it would still be there even if it looked funny. What if the length were 2 feet? You'd have a wider play space. 3 feet, 4 feet, 10 feet, 20 feet, 30 feet, 35 feet. You would have a play space. So X can be anything between, any measurement between 0 and 40, but it cannot equal 0 and it cannot equal 40. So the domain of this play space is going to be all the measurements in between 0 and 40. In real life, the domain is determined by what would make the problem we're looking for not exist. If one of the sides were 0, the play space would not exist. If one of the sides were 40, the other side would be 0 and the play space would not exist. So these are the two numbers that would make the play space not exist. Okay, now what they have done is they have graphed the function x times 40 minus x. And they're asking you, well, golly darn, which one is it? So think back to intermediate algebra. I'm going to go ahead and distribute this x into the parentheses, and what that will give me is 40x minus x squared, which can be rewritten more properly, x, 40x, as negative x squared plus 40x. Now, something you learned last semester or spring semester, whenever you took intermediate algebra, is that when your quadratic term is negative, you have a cupped down parabola. If you had x squared plus 40x, that would look like this. But negative x squared plus 40x is going to look like that. We're going to be doing something called transformations after the exam, and a negative in front of the leading term causes it to be flipped upside down. And that's an always thing. So rather than looking like this, it's going to look like this, which is why you have that green star there. It's definitely not a straight line, not if you've got a variable raised to any power besides 1. So it's not a straight line, and it's not an absolute value because you don't see an absolute value anywhere in there. So neither of these would be correct. And the problem would be to decide between this, which is the graph of a quadratic function, and this, which is the graph of a quadratic function. But this one is upside down. called cup down. Okay, so we're going to look at this closer. We're looking at this one right here, number 2. Now they ask us, what are the dimensions of the maximum area? So here's a review of maximizing a quadratic function. Well, it has to be cupped down like that. This vertical axis is a of x. Remember, it's the y-axis, and when you have a function in this form, this part of it is always just y. So the area, here you have 400. That's going to be the maximum area. Now, how do we find the dimensions that will give us a maximum area of 400? Well, there's no way to find W straight out, but there is a way to find X. This is the X-axis, and X is the length. Remember, they told us that. So all I have to do is go to the maximum area and then come down to the X-axis. To here. Now, this is halfway to 40. You don't suppose it's 20. Well, it is. But let's see what this is. Is this 5, 10, 15, 20, 25, 30, 35, 40? Yes, each of these is 5. So this is 20. So now we know that the length is going to be 20 feet. The length of the maximum area. So all we have to do now is go back up here and find the width. Well, okay, we'll have X, well, here, W is going to be 40 minus X, even easier. Well, if X is 20, then we'll have 40 minus 20, which is 20. So the width is also 20. X is going to be 20, and W is going to be 20. And what that means is that this is a square and not a rectangle. Well, a square is a type of rectangle, but forget that for a minute. This is not a figure where the length is longer than the width. This is a square where the length equals the width. And that's something for you to stick back in your memory, that whenever you want to maximize a rectangular area, the way to maximize the area is to make the figure into a square. That gives you your biggest bang for the buck. Discussion. I'm going to save while you think about questions. It's interesting that we're talking about what ends up being a square, but even then a square is really a rectangle, a special kind of rectangle. So when we graph it though, there's nothing rectangular at all about this graph. It's curved. It's a parabola. So just because you graph it doesn't mean the graph you get is going to be a square, even though you know it's going to be a square. But this is the relationship between the area and the length. If X is 5 feet, this is going to be your area. And if X is 10 feet, this is going to be your area. And if X is 15 feet, this is going to be your area. And if X is 20 feet, that's your area. But what about if X is 25 feet? That's your area, again, over here. So what does this tell you? Remembering back, X equals 20 is also going to be, or appears to be, the line that we call the axis of symmetry. We're going to be finding all that again, but not yet. But this problem kind of sort of gets you ready for thinking in terms of graphs and whatnot. Silence. Okay. I would be glad to talk to you about it. However, we do have time, so I'm going to go back to this and do this problem right here. Okay, so here we are back at solving radical equations. I'm going to square the left side, and I'm going to square the right side. That'll give me 37 minus 3x. And over here, I'll have x minus 3. See, these are all pretty much alike. So we'll have x squared minus 3x minus 3x plus 9 equals 37 minus 3x. So this will be x squared minus 6x plus 9 equals 37 minus 3x. So I will add 3x to both sides, so it will zero out over here. Yep, okay, plus 3x. And then I'll subtract 37 so that I'll get 37 minus 37, and that's 0. Minus 37. So I'll have x squared Negative 6x plus 3x is negative 3x. And 28, negative 28. Okay, so x squared minus 3x minus 28 equals 0. Now this is not exactly like the problem we had before, the problems, because both of these problems ended up with positive constants. Yeah, plus 18. So that when I factored, I would factor two positives times each other or two negatives times each other because this was positive. For instance, 18 down here is positive and 84 is positive. But now we're going to have a negative constant, and I'm going to be factoring negative 28. So let's just look at plain old boring 28 for a minute. And oh. And I will come back and change it, don't worry. Let's see, 28, just 28 would equal 1 times 28 and 2 times 14 and 4 times 7. And then it starts repeating 7 times 4, 14 times 2. Okay, so negative 28. Well, the way you get a negative number is you multiply a negative number times a positive number, or a positive number times a negative number. So here I'm going to make the first numbers negative and the second numbers positive, or the first numbers positive and the second numbers negative. No, 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 no. 28, 14, and 7. Okay. So now, I need the two numbers that will add up to negative 3, and here they are. 4 plus negative 7 equals negative 3. So I will come over here and I will factor. And 4 is going to be positive, and 7 is going to be negative, like that. And then I'll set each factor equal to 0. So x plus 4 equals 0, and x minus 7 equals 0. So subtract 4, x equals negative 4. And add 7, x equals 7. So now my two possible answers are negative 4 and positive 7. So what I'm going to do is I'm going to check both answers. Okay, well, negative 4 minus 3 equals the square root of 37 minus 3 times negative 4. So negative 7 over here equals the square root of 37 plus 12, because negative times negative is positive. Now negative 7 equals the square root of 49, and the square root of 49 is positive 7. So you've got negative 7 equals positive 7, which is false. It's not true. Okay, so we've got to knock this out and knock this out. Now we're going to try 7. X equals 7. X minus 3 equals the square root of 37 minus 3x. So 7 minus 3 equals the square root of 37 minus 3 times 21. Oh, no. You see what happens? I know that 3 times 7 is 21, and I did it in my head, and I stuck a 21 in there. You have to be careful, and I wasn't being careful. I'm glad I caught it. 7. All right, so 4 equals the square root of 37 minus 21. So 4 equals the square root of 16. 4 equals 4. Yay for us, that's true. So the only solution is x equals 4? No, x equals 7. Yeah, this is the one that gave a true answer. So there you go. Those are our 2 homeworks. Since your test is the early part of next week, I thought it would be kind of cool to go over your questions about the practice exam. So let's go over the practice exam on Wednesday. Meanwhile, try to get all caught up on your homework, because both the practice exam and the real exam have nothing but homework problems in them. If you've already done your homework, you're that much closer to being able to make an A on the test.
Thank you.
Thank you.
Okay, bye.
Bye.
Thank you.
Thank you.
Thank you.
Thank you.
If there was a homework assignment that we did not finish, are we able to go back in and complete it?
Yes. And if you find you're not, let me know and I'll open it up.
Okay, thank you.
You're welcome. Oops. Okay, a lot of you still here.